Alright guys, so today we're continuing with linear relationships, and we're going to be looking at three things today. First step is solving equations, next one is solving inequalities, and then the next one will be a system of equations. So coming back up here, we're only going to do a couple examples. If you see these questions and you feel like practicing some, feel free to do that. Okay, so the first thing we need to do is remember our rules for solving equations. So remember that the goal is to, actually let me just use my typing thing here. Remember we want to isolate the variable. That is the goal here. So basically that means by itself. Okay, the way we do that is, if you remember, you get the variables on one side, then you get the constants on one side, and then you just solve. I can talk more about that once we get there. So let's just get started with working it out, and let's look at this first example here. So notice that we have this piece right here real fast, and this is called the distributive, in case you don't remember. And so what that is, in case you don't remember, is what you do is you take this outside number, remember the sign, and you distribute it to everything on the inside. And what that means is you multiply it. So here we do 5 times x, which is 5x. Then we do, now remember this is a positive 5. I'm going to do this example down here and show you the opposite here in a moment. Anyways, so that's 5x, positive 5 times positive 6 is just plus 30. And then you just drop the rest of this stuff down. So it's a 37, it's a negative 3, and that's plus 5x. So I know this got a little messy here, but so this is a negative 3. Actually, you know what? I'm going to rewrite this for y'all real fast so y'all can see a little bit better. So it's 37 equals negative 3 plus 5x plus 30. So the next step here is we need to take this negative 3 and this positive 30 and put them together. You can use calculators to do it. You should now have 37 equals 5x, and then when you combine these you get a positive 27. So we did step 1 of get the, actually we're not even done step 1. So what we're doing now is we need to get that variable by itself. Okay, so notice that the 5x is not by itself. So we need to get this stuff over here. So we subtract this 27 from both sides because we want just the variable. So this cancels out, 5x drops down, and then this gives us 10. So we have 10 equals 5x. So notice that here we did step 1 and 2 at the same time. That sometimes happens, sometimes it doesn't. So now variables on one side, constants on the other side. So now we just need to finish solving. And what that means in this case is this is a coefficient, 5x, so we need to divide by 5 to both sides to get rid of it. Again, remember we use inverse or opposite operations to solve. So these 5's cancel out and the x drops down. 10 divided by 5 is 2. Boom, 2 equals x. Okay, moving on, I'm going to go ahead and slide this down. And I'm going to let you see this example here. So here is another distributive that we need to do. Okay, but if you notice, this is a negative 6. And notice that we have a negative here, so I'll talk about that in a second. So first step is, again, the distributive is the outside term times everything on the inside. So negative 6 times 1 is just a negative 6. Now, you have to pay attention to the sign in the middle, because that is the sign of what this is. So what this actually is this is a negative 6 times a negative 5. In other words, a negative times a negative means our answer is going to be positive. So now 6 times 5 is 30v. So if you notice, we end up with a positive here. People mess this up all the time, guys, and you can't. Okay? You got to keep the signs attached to the number. Anyways, moving on, now it's again, I want this variable by itself. So let me take this plus 6, or take this negative 6 and get rid of it by adding a negative or a positive 6 here. So now this is 30v equals 60. Again, this is a coefficient, so we need to divide to cancel it out. So this cancels out here. We get v equals 2. So we got the same answer for both of these. And that's basically it with equations. So now we're going to come over here to the next page, and we're going to mess with inequalities. Now, inequalities, remember that we solve inequalities. We solve inequalities the exact same way as equations. But we have to pay attention to the symbol. Because if you remember, we can do flip rules. Okay? So what that means is there's two situations. Situation 1, if you multiply / divide by a negative, the symbol flips. Or we could have situation 2, which is where if you have a variable on the right and you move it to the left, the symbol flips. Now, I'm going to put a little star here because I'm worried y'all are going to interpret this the wrong way, and I'd rather let you see an example before we do it. So let's just, let's do this one here. We're going to do 9 and 11, just so you're aware. And both of those are going to give you an example of how this works. So if we look at 9, you can just draw your line through the inequality sign, just like normal. So here you can see that we need to get rid of this 5 so that the variable is isolated. So we subtract 5. Again, just use your inverse operations. Negative 7v greater than or equal to, and then this is a negative 79, minus 5, that's going to give you a negative 84. Again, you can feel free to use calculators. Now, this is rule 1. Right here, this is rule 1. This coefficient is negative. So the rule is you divide by the coefficient. But notice, I'm doing what rule 1 says. If you divide by a negative, the symbol flips. So please pay attention. I divided by negative 7, so the v still drops down. Greater than or equal to becomes less than or equal to. And then you do negative 84 divided by negative 7, which gives you a positive 12. There you go. V less than or equal to 12. And again, if you want to know how to graph it, this one, because it's an or equal to, it's a filled in dot. And because it's less than or equal to, it points to the left. I know these arrows look terrible. All right, so now I'm going to go ahead and I am going to do rule 2, all in green. Okay? And I'm going to do it down here. So if you need to come back and look at this, that's fine. But I am going to scoot this up. So, moving this down, I picked this one for 2 reasons. Because 1, it's going to show us an example of number 2. But it's also going to show us another way to do it. So notice how this a plus 1 is all on top of this 2. What this means is you have to get rid of it. Now, I know equations and inequalities can be complex because if you look over here, you would solve this one differently than you would solve this one. Because if you look at this one, it's just the x that's divided by 2. Here, it's all of this that's divided by 2. So that's why this one's a little bit different than this one. Anyways, to get rid of this divide by 2, you need to times by 2 to both sides. So 4 times 2 is 8, greater than. These cancel out, so this a plus 1 drops down. Now, we need to subtract this 1, because we want the variable by itself. Cancels out. 8 minus 1 is 7, greater than a. Now, if you notice, compared to the earlier one, notice here that the variable is on our left. Now, with equations, it really doesn't matter which side they're on, but with inequalities, it does. Inequalities, when you finish, you always want the variable on this left side of the symbol. Here, it's not. So what I need to do is I need to take this a and the 7, and I need to swap their positions. So let me do that. But if you notice what I did is I changed my symbol. Because if I have a variable on the right and I move it to the left, the symbol flips. this is what rule 2 looks like, because you finish solving and the variable's on the right side, but we don't want that. We want it over here. So what we do is we swap their positions, but we flip the symbol in the process. And then again, since this is a less than, it's an open circle, but it still points to the left. And I'll kind of bold that in a little bit. All right. Next, if we go to this last page, this is going to be system of equations. I'm going to show y'all a quick way of doing it. So first off, this one will be the one that makes the most sense to y'all because it looks similar to what we were doing yesterday. So first things first is you got to graph these lines. So we'll graph this one. Again, always start with your y-intercept, -4, and then use your slope. So this is 1/3. So it's 1 rise, 3 run. Up 1 over 3. Up 1 over 1, 2, and then it would be like here. So now we just take a line, we connect these, and boom. Nice line. Now we're going to do this one. Oop, I'm still on the line. Now we're going to do this one. So this one, again, your y-intercept is +4, so we go up to +4. Now it's -7 over 3. It does not matter which of these you make negative, so you can either do -7 over 3, or you can do 7 over -3. Either works, doesn't matter. I'm going to do this one here. So we go down 7, 1, 2, 3, 4, 5, 6, 7, right here. And then we go from here, we go 3 to the right because it's a +3. 1, 2, 3. And if you notice, I can go ahead and finish graphing this line, but if you notice, what happens is these lines intersect where these lines, they intersect right where this earlier point was. That is the solution. To solve it, you find where they cross. And what that means is we just basically, we're solving for x, or rather you can just put the coordinate pair, right? So here, x is 3, and y is -3. So that's our solution for this one. Now, there's other ways of solving these, and I'm going to show y'all one other way before I run out of time with a simpler one, okay? So what you can also do is, if you just follow me down here, you can always take these, substitute them in to check that you're correct, okay? We just don't have time in the video for it, or I would do it. So here, what you can actually do is you can take the 2. Actually, do I have a simpler one that I can work with? No, I don't. Let's just use this one. I'll go real quick because we're running out of time. So take these equations and set them equal to each other. So 1/3x plus 3 equals 2x minus 2. So just take the x parts and put them equal to each other. Solve for x. So +2 plus 2, you get 1/3 x. You get 1/3 x plus 5 equals 2x. You are going to subtract that 1/3 x to get 5 equals 5/3 x. And then what you would do is you would do that divide by the coefficient rule. So you would divide by 5/3, which ends up doing times 3/5, because remember, we multiply by the reciprocal. So these cancel out. Here, we're going to do 5 times 3/5, which is going to give us 15/5, which is going to give us 3. So we get 3 equals x. Now you take this information, and you go right back up to this earlier equation, and you substitute in x. So here, what you can do is you can take that 3x and substitute it in here. And what that'll look like is this right here. Y equals 2 times 3 minus 2. Solve this. 6 minus 2, 4. Y equals 4. And now you have your solution. X is 3 and y is 4. And I could go back to, I don't have time, but I could go back to all of these and I could graph the lines, and you would see that they would cross at 3, 4 right here. Anyways, guys, I got about 10 seconds, so let me know if y'all have any help. Good luck on y'all's work, and have a good